Hello class. So today we're going to look at another example for chapter 12. It is an AICE question. This one's going to be a little bit different. This one's going to involve topics of chapter 12, so derivatives, how to find gradient, stuff like that, along with some coordinate geometry topics mixed in. Okay, so your assignment today will be something that's kind of similar to this. So let's get started. So we have a curve. So here's a line. This is the curve. This is the equation of the curve. Okay. The point where the line and curve intersect the x-axis is point A. The point where the curve intercepts the y-axis is B. And the point where the line intercepts the y-axis is C. Okay, so the diagram shows part of the curve which crosses the x-axis at A and the y-axis at B. Part I. Show that the equation of the line AC, so the equation of this line, is given by this formula. And then find the length of BC. Okay, so let's get started on I. Show that the equation of the line AC is 9x plus 4y equals 27. So if you're taking notes, you might want to pause it now so you can write this down. Okay, so in order to equation of a line, remember equation of a line is y minus y1 equals m x minus x1. So we need a point and we need the slope. Okay, so for AC, we need either A or C. Well, in this case, A is probably going to be the point defined, since we know it crosses this curve. Okay, so it has some relation to this curve that we can use. And then the slope, remember slope, if you don't have both points, to use a slope formula, how do you find slope? Remember, the derivative of the curve, when you plug in a value for x, gives you the slope. Okay, but let's go ahead and find the point first. Okay, so A intercepts the x-axis, so we know at point A, if it intercepts the x-axis, that means the y value of A is 0. And so how do we find x? Well, we just take the equation of line, plug in 0 for y, solve for x. So 0 equals 2 minus 18 over 2x plus 3. Okay. Add that term over to the right side. Multiply by this 2x plus 3 over to here. So I get 4x plus 6 equals 18. Subtract the 6. And so I get x is equal to 3. Okay, so now I know a point on a line AC. A, so I can use that in this formula. Now the only thing I'm missing is the slope. So the slope comes from taking the derivative of the curve and then plugging in the value that we know for x to get the slope. Alright, so y prime. Actually first, let me rewrite y using a negative exponent. Okay, so to take the derivative you have to have exponents. So this is on the bottom, so to write this up top I can write the whole thing to a negative 1. And that way I can take the derivative. Now my y prime, so derivative of 2 is 0. Bring down the negative 1. Negative 1 times negative 18 is positive 18. Okay, remember chain rule here. If you don't remember chain rule, you might need to review that. That was chapter 12 stuff. You leave what's inside alone, subtract 1, and then we multiply by the derivative of the inside of the parentheses. So derivative of 2x is 2, derivative of 3 is 0, so it's just times 2. So then y prime is 36 So that's the prime, that's the gradient. The gradient of what? That's the gradient of the tangent. So remember the tangent is the curve, is the line that's like this. So we just found the gradient of that line. Okay. And this may not be exactly to scale, but this should be perpendicular through here. Okay, so if this is the tangent, remember what the perpendicular line was called? The normal. How do we find the gradient of the normal if we know the gradient of the tangent? It's just going to be the opposite inverse. Okay, so let's find the gradient of the tangent first. So we have the tangent. Find the gradient, we just got to plug in a value for x. This value. So plug in 3 to here. So we got 36. That's 6 plus 3 is 9. I'm going to write it back underneath now, so I don't have to write a negative 2. I write it as a positive 2. So 36 over 81, which we can simplify that to 9 goes into both of those, 4 over 9. Okay, that's for the tangent. So because we don't want the slope of the tangent, we want the slope of the one going through it, the normal. That's opposite inverse. So that's negative 9 over 4. So now I have the slope for AC and a point for AC. So now I can simply do y minus 0. Okay. Simplify that down. You might have to rearrange it a little bit. I get y equals, I multiply by the 4, 27, add the 9x to the other side, and there you go. Okay. So we've shown that it is, equation of AC is that equation. Okay, now find the length of BC. So BC is here and here. So we need to find the length, that's the same thing as distance. So if I remember the distance formula, just from coordinate geometry, x2 minus x1 squared, y2 minus y1 squared, all under the square root. Okay, so in order to find the distance or the length, you have to know both points. So what do we know about both B and C? Okay, well if they're both on the y-axis, that means both of them have an x value of 0. How are we going to find the y values? Well, B is on the curve, so we're going to use the equation of the curve for B, and C is on the line of AC, so we're going to use the equation of AC to find C. Alright, so for B, use this formula, plug in 0 for x, y equals 2 minus 18 over 3, because 2 times 0 is 0. So we have y equals 2 minus 6, which is negative 4. Okay, so that should make sense. 0, negative 4. Now what about for C? We'll use the equation of the line for AC. We're just going to plug 0 in for x. So we get for y equals 27. So y is equal to 27 over 4. And just leave it as a fraction. Okay, don't worry about trying to use decimals. So now we have point B and point C. So you just plug them to this formula. Plug them into the formula. Be very careful with your math, with the fractions, and you'll come out with an answer of 43 over 4. If you keep it as fractions, which you should. If you end up doing decimals, remember round to 3 decimal places. Okay, and then just make sure it's equivalent to that. Okay, so hopefully that wasn't too bad. It's slightly different than the ones we've been doing. It's taking a little bit of knowledge from derivatives. Just knowing that the derivative of an equation of a curve is how you get slope. And then just mixing that into a bigger coordinate geometry problem. Okay, so to If anybody has questions on this problem, please message me and I try to clear those up. If not, you can start working on the assignment for today. Have a great day, everybody.